This is a problem 9.5 in your textbook, which asks you to compute the load-bearing capacity, that's VPN, of the column that's shown. And in 9.5, they say you got a 24 inch square column, so that's 24 by 24. It's reinforced with 12 number 10 bars. And you have an Fy of 60,000 psi and an F prime C of 4,000 psi. Now again, chapter 9 is really just, again, a setup chapter for what we will be talking about. The one formula in the chapter which looks at just axial design capacity of a column is given to you, and we talked about that before on page 267. All homework problem 9.5 is a application of that formula. So your area steel of 12 number 10 bars, the number 10 bar has an area of 1.27 square inches. You have 12 of those, and so your area is 15.24 square inches. This is a tied column, so the phi value when you're using a tied column is 0.65, and since it's 24 by 24, that's 576 square inches. So you can see there, I just pop all my numbers into the formula. The 560.76 right here, that is gross area minus the area of steel. Okay, and I run this out and it comes out to about 1,467 kips. So again, just a basic application of that formula for axial design capacity. The second homework problem that I'm going to show you in chapter 9, and again, this really isn't a design problem, but they call it a design problem, is just really applying that formula to determine the gross area of the column and then also the area of steel. So in this case, again, it gives us a service load, dead load of 300 kips, and a service live load of 500 kips. So the first thing you have to do is go ahead and factor those via the load combinations, and I do that in this first step up here, and I come up with 1,160 kips. I then set P sub u equal to the formula we just got done with in the previous problem, the design capacity formula. Again, this 9.10 is a tied column, so again the phi value is 0.65. I don't know gross area and I don't know area steel, so what I'll do here is I'll just go ahead and assume that I'm going to use about 2% gross area for my area steel. Remember, this comes from the fact that I can use anywhere from 1% to 8%, although it's more likely that I'm going to be down in the 1, 2, 3% range than it would be to see this column up in the 5, 6, 7, 8% range. So substituting 0.02 gross area for area steel, I just go ahead and run through my formula and I solve for gross area. And gross area comes out to be a little bit greater than 492 square inches. This problem says use a square column, a square tied column, so I'm going to say 24 by 24. I could have said a 23 by 23, but I just used even inches. So that's a gross area of 576. What I'm then going to do is just pop gross area in to the formula there, 576, and now I'm going to run through the formula once again, now solving for area steel as my variable. So the area steel that you come up with is a little bit under 5 square inches, 4.82. That's not quite 1%, so if you're living by the code, I'd probably bump that up and use actually 1%.